Alright, in this video we are going to learn about factor by grouping, which is a new technique that allows you to factor more complex, usually quadrinomials or trinomials. So we'll launch right into it. So the first thing I want to do is remind you of the previous three ways we've learned to factor. The first was factoring common factors. That's where you look at all the terms in the polynomial and you see what all of them have in common, and then you factor it out to the front. So let me just make a simple example just so you can visualize it. Maybe you have 20x squared plus 10x. And you notice that they both have a 10 in common, largest numerical common factor, and they both have at least x to the first power, variable common factor. And if you factor out or divide each term by 10x, in the first term you're left with 2x and plus, and the second term you're left with 1. So this is essentially the reverse of distribution. If you were to distribute this back in, after you factored it, you'll come back to what you started with before you factored. Simple quadratics are things that are in the form of x squared plus bx plus c. Okay, and these we learned how to factor. It's the opposite of FOIL, or double distribution. And because they start with an x squared at the front, you put an x times x in the front. And then the two numbers that go here and here, they have the special property that they multiply together when you do last times last to equal the c value. And then when you do the inners and you do the outers and you add those two pieces together, you have to get the b value. So you had to come up with two numbers that multiply together to get c and add up to get b. So that was simple quadratics. Harder quadratics are very similar, but they have a numerical coefficient in the front. So instead of just being an x squared in the front, which makes an x and an x, you might have something like this, where there's actually a number in the front. And so the way that I taught you to do them before was the same way. You write your parentheses, but now instead of just having an x and an x, the front two numbers would need to multiply together to give you a, and still the back two numbers would need to multiply together to give you c, but the middle is a lot trickier because when you multiply your insides and you multiply your outsides, it's not just the two numbers added together because you might have had a number in the front. So if that didn't make any sense, rewatch the video on factoring to kind of refresh your memory. But anyway, this is a review of the three ways that we've learned so far. So this new method, it's going to allow you to do some more quadratics that you might not have been able to do with these three methods. Okay, so we'll try to learn this new technique by doing an example. Here's an equation that you might have, something that's a cubic instead of a quadratic. So you would start by looking for common factors, but you can see between all these, there's no variable in common and there's no number in common. And furthermore, it's got a cube in the front. It's a cubic equation, not a quadratic. So offhand, you wouldn't be able to use any of those three techniques that we previously learned. But the thing that you can do is called factor by grouping, and you'll see eventually it will lead us to something like this. So you could always try it the old way, guess and check. To get x cubed, you might presume you need an x squared and an x. And then to get a 15, you might need a 5 and a 3 somehow, and that has to equal this two middle terms. But notice these two middle terms, they did not combine together. Normally when we were doing these type of problems in the past, the two middle terms combined together. But now, because we're dealing with x squared in the first term and just x in the second term, the middle terms won't match up and they won't combine. So let me tell you this factor by grouping technique. You look at the first two pieces and you notice the ratio of these two is a 1 to 5 ratio. This one has a 1 in front, this one has a 5. And then you look at the back two terms and you notice this one also has a 1 to 5 ratio. Anytime you have the same ratio, it's likely that the problem is going to be a factor by grouping type of problem. So the way that you do it is you factor the first two terms by themselves by common factors. So what do we have in common here? It turns out we have an x squared in common, and just in the front two, that leaves behind x plus 5. Okay, now you look at the next thing and you see what does it have in common. Okay, so plus. Then in the back two, we have a negative 3 in common. So we take out a negative 3, and if we take out a negative 3, we leave behind in this first term an x, and the second term plus 5. Okay, and now here's where it gets a little weird. Something maybe that not something you've seen before. This whole piece could now be considered one term, and this whole piece could now be considered one term. And we can factor a common factor out of these more complicated terms. So the thing that this whole term has in common with this whole term is x plus 5 and x plus 5. It's in both of them. So I can factor out x plus 5 to the front, and then I can see what am I leaving behind. In the first term, if I factor out the x plus 5, I'm leaving behind an x squared. And then in the second term, if I factor out the x plus 5, I'm leaving behind plus a negative 3, but I'll just write that as minus 3 since it's the same thing. Okay, and then actually that did it. That factored it for us. So if you can factor by grouping, you do the first two separately and the last two separately, and if they have something left behind in common, then this method will definitely work. And if you had gone back up here and tried it the old way, you could figure a 5 and a 3. I need a plus 5x squared, so opposite my x squared, I'm going to need a plus 5. And I need a negative 3x, so opposite my x, I'm going to need a negative 3. This method really isn't so bad, and a lot of times you can figure it out. But if you want a surefire way, and it's very common in textbooks to have this factor by grouping method, where the ratio of the coefficients in the front two is the same as the back two. Okay, so we'll do one more example. Here's one that instead of using just one variable, it uses two variables. But again, you can look. These terms, they both have an x, okay, and the ratio is 4 to 10. These terms, neither one has an x, and the ratio is 10 to 25, which reduces to 4 to 10. So we'll see what we can factor out here. We can take out a 2 and an x, leaving behind 2y plus 5. That's just the front two. Plus, now from the back two, we can take out, what, a 5, leaving behind a 2y plus 5. And now, from this entire first term and this entire second term, we can take out the 2y plus 5, leaving behind the 2x from the first term and the 5 from the second term. So, it's a pretty cool method. And the way to try to see if you want to use this method is look at your original problem. Still, you can try to factor out if you have common factors. That can be a useful thing to do. If you don't have common factors that can be factored out, then let me see this right. Yeah, 10, 10. If you don't have common factors that can be factored out, then it's possible that you want to see if it's a quadratic, and if it's not a quadratic, then you can try this factor by grouping method. It's probably one of the least common out of all the methods of factoring, but it's still a useful one to know how to do. Okay, good luck with the assignment.